The lighting system of a motor vehicle consists of lighting and signaling devices mounted or integrated to various parts of a motor vehicle. These may include the front, sides, rear and, in some cases, the top of the vehicle. The purpose of this system is to provide illumination for the driver. This enables safe vehicle operation after dark and increases the conspicuity of the vehicle. It also informs of the vehicle's presence, position, size, direction of travel, and the driver's intentions regarding direction and speed of travel. History: early road vehicles used fueled lamps, before the availability of electric lighting. For example, the first introduced Ford Model T used carbide lamps for headlamps and oil lamps for tail lamps. It did not have all-electric lighting as a standard feature until after several years on the market. Dynamos for automobile headlamps were first fitted around 1908 and became commonplace in 1920s automobiles. Tail lamps and brake lamps were introduced around 1915, and by 1919 dip headlamps were available. The sealed-beamed headlamp was introduced in 1936 and standardized as the only acceptable type in the USA in 1940. Self-canceling turn signals were developed in 1940. By 1945 headlamps and signal lamps were integrated into the body styling. Halogen headlamp light sources were developed in Europe in 1960. HID headlamps were produced starting in 1991. In 1993, the first LED tail lamps were installed on mass-production automobiles. LED headlamps were introduced in the first decade of the 21st century. Color of light emitted: the color of light emitted by vehicle lights is largely standardized by long-standing convention. It was first codified in the 1949 Vienna Convention on Road Traffic and later specified in the 1968 United Nations Convention on Road Traffic. Generally, but with some regional exceptions, lamps facing rearward must emit red light, lamps facing sideward and all turn signals must emit amber light, while lamps facing frontward must emit white or selective yellow light. No other colors are permitted except on emergency vehicles. Forward illumination: forward illumination is provided by high and low beamed headlamps, which may be augmented by auxiliary fog lamps, driving lamps, or cornering lamps. Headlamps. Dipped beam. Dipped beam headlamps provide a light distribution to give adequate forward and lateral illumination without dazzling other road users with excessive glare. This beam is specified for use whenever other vehicles are present ahead. UN regulations for headlamps specify a beam with a sharp, asymmetric cutoff preventing significant amounts of light from being cast into the eyes of drivers of preceding or oncoming cars. Control of glare is less strict in the United States-based Society of Automotive Engineers beam standard. It is contained in Federal Motor Vehicle Safety Standard 108. Main beam. Main beam headlamps provide an intense, center-weighted distribution of light with no particular control of glare. Therefore, they are only suitable for use when alone on the road, as the glare they produce will dazzle other drivers. ECE and Japanese regulations permit higher intensity, high-beamed headlamps than allowed under U.S. regulations. Auxiliary lamps, driving lamps. Auxiliary high-beam lamps may be fitted to provide high-intensity light to enable the driver to see at longer range than the vehicle's high-beamed headlamps may be fitted. Such lamps are most notably fitted on rallying cars, and are occasionally fitted to production vehicles derived from or imitating such cars. They are common in countries with large stretches of unlit roads, or in regions such as the Nordic countries where the period of daylight is short during winter. Driving lamp is a term deriving from the early days of nighttime driving, when it was relatively rare to encounter an opposing vehicle. Only on those occasions when opposing drivers passed each other would the low beam be used. The high beam was therefore known as the driving beam, and this terminology is still found in international UN regulations, which do not distinguish between a vehicle's primary and auxiliary upper driving beam lamps. The driving lamp term has been supplanted in U.S. regulations by the functionally descriptive term auxiliary high beam lamp. Many countries regulate the installation and use of driving lamps. For example, In Russia each vehicle may have no more than 3 pairs of lights including the original equipment items, and in Paraguay auxiliary driving lamps must be off and covered with opaque material when the vehicle is circulating in urban areas. Front fog lamps. Front fog lamps provide a wide, bar-shaped beam of light with a sharp cutoff at the top, and are generally aimed and mounted low. They may produce white or selective yellow light, and are intended for use at low speed to increase the illumination directed towards the road surface and verges in conditions of poor visibility due to rain, fog, dust or snow. They are sometimes used in place of dipped beam headlamps, reducing the glare back from fog or falling snow, although the legality varies by jurisdiction of using front fog lamps without low-beamed headlamps. In most countries, weather conditions rarely necessitate the use of fog lamps, and there is no legal requirement for them, so their primary purpose is frequently cosmetic. They are often available as optional extras or only on higher trim levels of many cars. An SAE study has shown that in the United States more people inappropriately use their fog lamps in dry weather than use them properly in poor weather. Because of this, use of the fog lamps when visibility is not seriously reduced is often prohibited in most jurisdictions. For example, in New South Wales, Australia, the driver of a vehicle must not use any fog light fitted to the vehicle unless the driver is driving in fog, mist or under other atmospheric conditions that restrict visibility. The respective purposes of front fog lamps and driving lamps are often confused, due in part to the misconception that fog lamps are necessarily selective yellow, while any auxiliary lamp that makes white light is a driving lamp. Automakers and aftermarket parts and accessories suppliers frequently refer interchangeably to fog lamps and driving lamps. Cornering lamps. On some models, white cornering lamps provide extra lateral illumination in the direction of an intended turn or lane change. These are actuated in conjunction with the turn signals, though they burn steadily, and they may also be wired to illuminate when the vehicle is shifted into reverse gear, as is done on many Saabs and Corvettes. American technical standards contain provisions for front cornering lamps as well as for rear cornering lamps. Cornering lamps have traditionally been prohibited under international UN regulations, though provisions have recently been made to allow them as long as they are only operable when the vehicle is traveling at less than 40 km per hour. Spotlights, police cars, emergency vehicles, and those competing in road rallies are sometimes equipped with an auxiliary lamp, sometimes called an alley light, in a swivel-mounted housing attached to one or both the pillars, directable by a handle protruding through the pillar into the vehicle. Until the mid-1940s, these spot lamps could be found as standard equipment on expensive cars. Until the mid-1960s, they were commonly offered by automakers as model-specific accessory items. Spot lamps are used to illuminate signs, house numbers, and people. Spotlights can also be had in versions designed to mount through the vehicle's roof. In some countries, for example in Russia, spotlights are allowed only on emergency vehicles or for off-road driving. Conspicuity, signal and identification lights. Conspicuity devices are the lamps and reflectors that make a vehicle conspicuous and visible with respect to its presence, position, direction of travel, change in direction or deceleration. Such lamps may burn steadily, blink, or flash, depending on their intended and regulated function. Front position lamps. Front position lamps, known as parking lamps, or parking lights in the US and Canada, parkers in Australia and front side lights in British English provide nighttime standing vehicle conspicuity. They were designed to use little electricity, so they could be left on for periods of time while parked. Despite the UK term, these are not the same as the side marker lights described below. The front position lamps may emit white or amber light in the United States and Canada. Elsewhere in the world they must emit only white light. Colloquial city light terminology for front position lamps derives from the practice, formerly adhered to in cities like Moscow, London and Paris, of driving at night in built-up areas using these low-intensity lights rather than headlamps. In Germany, the STVZO calls for a different function also known as parking lamps, with the vehicle's ignition switched off. the operator may activate a low-intensity light at the front and rear on either the left or the right side of the car. This function is used when parking in narrow unlit streets to provide parked vehicle conspicuity to approaching drivers. This function, which is optional under UN and US regulations, is served passively and without power consumption in the United States by the mandatory side marker Ret Reflectors. Daytime running lamps. Installation. Some countries permit or require vehicles to be equipped with daytime running lamps. Depending on the regulations of the country for which the vehicle is built, these may be functionally dedicated lamps, or the function may be provided by the low-beam or high-beamed headlamps, the front turn signals, or the front fog lamps. Passenger cars and small delivery vans first type approved to UN Regulation 48 on or after February 7, 2011 must be equipped with DRLs. Large vehicles type approved since August 2012 must be so equipped. Functional piggybacking, such as operating the headlamps or front turn signals or fog lamps as DRLs, is not permitted. The EU directive requires functionally specific daytime running lamps compliant with UN Regulation 87 and mounted to the vehicle in accord with UN Regulation 48. Prior to the DRL mandate, countries requiring daytime lights permitted low-beamed headlamps to provide that function. National regulations in Canada, Sweden, Norway, Slovenia, Finland, Iceland, and Denmark require hardwired automatic DRL systems of varying specification. DRLs are permitted in many countries where they are not required, but prohibited in other countries not requiring them. Front, side, and rear position lamps are permitted, required or forbidden to illuminate in combination with daytime running lamps, depending on the jurisdiction and the DRL implementation. Likewise, according to jurisdictional regulations, DRLs mounted within a certain distance of turn signals are permitted or required to extinguish or dim down to parking lamp intensity individually when the adjacent turn signal is operating. Intensity and color. UN Regulation 87 stipulates that DRLs must emit white light with an intensity of at least 400 candela on axis and no more than 1200 candela in any direction. In the US, daytime running lamps may emit amber or white light, and may produce up to 7,000 candela. This has provoked a large number of complaints about glare. Dim dip lamps. UK regulations briefly required vehicles first used on or after April 1, 1987 to be equipped with a dim dip device or special running lamps, except such vehicles as comply fully with UN Regulation 48 regarding installation of lighting equipment. A dim dip device operates the low-beamed headlamps at between 10% and 20% of normal low-beam intensity. The running lamps permitted as an alternative to dim dip were required to emit at least 200 candela straight ahead, and no more than 800 candela in any direction. In practice, most vehicles were equipped with the dim dip option rather than the running lamps. The dim dip systems were not intended for daytime use as DRLs. Rather, they operated if the engine was running and the driver switched on the parking lamps. Dim dip was intended to provide a nighttime town beam with intensity between that of the parking lamps commonly used at the time by British drivers in city traffic after dark, and dipped beams. The former were considered insufficiently intense to provide improved conspicuity in conditions requiring it, while the latter were considered too glaring for safe use in built-up areas. The UK was the only country to require such dim dip systems, though vehicles so equipped were sold in other Commonwealth countries with left-hand traffic. In 1988, the European Commission successfully prosecuted the UK government in the European Court of Justice, arguing that the UK requirement for dim dip was illegal under EC directives prohibiting member states from enacting vehicle lighting requirements not contained in pan-European EC directives. As a result, the UK requirement for dim dip was quashed. Nevertheless, dim dip systems remain permitted, and while such systems are not presently as common as they once were, dim dip functionality was fitted on many new cars well into the 1990s. The Jaguar XJS used this system, including the final Celebration models produced up until 1995. Lateral, side marker lights and reflectors. In the US, amber front and red rear side marker lamps and ret reflectors are required. The law initially required lights or ret reflectors on vehicles made after January 1, 1968. This was amended to require lights and ret reflectors on vehicles made after January 1, 1970. These side-facing devices make the vehicle's presence, position and direction of travel clearly visible from oblique angles. The lights are wired so as to illuminate whenever the vehicle's parking and tail lamps are on, including when the headlamps are being used. Front amber side markers in the United States may be wired so as to flash in synchronous phase or opposite phase with the turn signals, but are not required to flash at all. Side markers are permitted outside the US, Canada, but not required. If installed, they are required to be brighter and visible through a larger horizontal angle than US side markers, may flash only in synchronous phase with the turn signals, and they must be amber at the front and rear unless the rear side marker is incorporated into the main rear lamp cluster, in which case it may be red or amber. Some Japanese, European, British and US brand vehicles have side markers in Europe and other countries where they are not required. Japan's recent accession to international UN regulations has caused automakers to change the rear side marker color from red to amber on their models so equipped in the Japanese market. Turn signals. Turn signals are formerly called directional indicators, or directional signals, and informally known as directionals, blinkers, indicators, or flashes are blinking lamps mounted near the left and right front and rear corners of a vehicle, and sometimes on the sides, activated by the driver on one side of the vehicle at a time to advertise intent to turn or change lanes toward that side. Electric turn signal lights date from as early as 1907. The modern turn signal was patented in 1938 and later most major automobile manufacturers offered this feature. As of 2013 most countries require turn signals on all new vehicles that are driven on public roadways. Alternative systems of hand signals were used earlier, and remain common for bicycles. Hand signals are also sometimes used when regular vehicle lights are malfunctioning or for older vehicles that are not so equipped. Some cars from the 1920s to 1950s used retractable semaphores called trafficators rather than flashing lights. They were commonly mounted high up behind the front doors and swung out horizontally. However, they were fragile and could be easily broken off and also had a tendency to stick in the closed position. As with all vehicle lighting and signaling devices, turn signal lights must comply with technical standards that stipulate minimum and maximum permissible intensity levels, minimum horizontal and vertical angles of visibility, and minimum illuminated surface area to ensure that they are visible at all relevant angles, do not dazzle those who view them, and are suitably conspicuous in conditions ranging from full darkness to full direct sunlight. Side turn signals. In most countries, cars must be equipped with side-mounted turn signal repeaters to make the turn indication visible laterally rather than just to the front and rear of the vehicle. These are permitted, but not required in the U.S. As an alternative in both the United States and Canada, the front amber side marker lights may be wired to flash with the turn signals, but this also is not mandatory. In recent years, many automakers have been incorporating side turn signal devices into the side mirror housings, rather than mounting them on the vehicle's fenders. Some evidence suggests these mirror-mounted turn signals may be more effective than fender-mounted items. Electrical connection and switching. Turn signals are required to blink on and off, or flash, at a steady rate of between 60 and 120 blinks per minute. International Union regulations require that all turn signals flash in simultaneous phase. U.S. regulations permit side marker lights wired for side turn signal functionality to flash in opposite phase. An audio and/or visual telltale indicator is required, to advise the driver when the turn signals are activated and operating. This usually takes the form of one or two green indicator lights on the vehicle's instrument cluster, and a cyclical tick-tock noise generated electromechanically or electronically. It is also required that the vehicle operator be alerted by much faster or slower than normal flashing in the event a turn signal light fails. Turn signals are in almost every case activated by a horizontal lever protruding from the side of the steering column, though on some vehicles it protrudes from the dashboard. The outboard end of the stalk is pushed clockwise to activate the right turn signals, or anti-clockwise for the left turn signals. In most cases, the signal stalk is on the outboard side of the column, the left side in a left-hand drive car, or the right side in a right-hand drive car. Regulations do not specify a mandatory location for the turn signal control, only that it be visible and operable by the belted-in driver, and at least in North America that it be labeled with a specific symbol if it is not located on the left side of the steering column. The international UN regulations do not include analogous specifications. Virtually all vehicles have a turn indicator self-canceling feature that returns the lever to the neutral position as the steering wheel approaches the straight-ahead position after a turn has been made. Beginning in the late 1960s, indicating for a lane change was facilitated by the addition of a spring-loaded momentary signal on position just shy of the left and right detents. The signal operates for however long the driver holds the lever partway towards the left or right turn signal detent. Some recent vehicles have an automatic lane change indication feature. Tapping the lever partway towards the left or right signal position and immediately releasing it causes the applicable turn indicators to flash 3 to 5 times. Some transit buses, such as those in New York, have had, since at least the 1950s, turn signals activated by floor-mounted momentary contact foot switches on the floor near the driver's left foot. The foot-activated signals allow bus drivers to keep both hands on the steering wheel while watching the road and scanning for passengers as they approach a bus stop. New York City Transit bus drivers, among others, are trained to step continuously on the right directional switch while servicing a bus stop, to signal other road users they are intentionally dwelling at the stop, allowing following buses to skip that stop. This method of signaling requires no special arrangements for self-cancellation or passing. Sequential turn signals. Sequential turn signals are a feature on some cars wherein the turn signal function is provided by multiple lit elements that illuminate sequentially rather than simultaneously. The innermost lamp lights and remains illuminated, the next outermost lamp lights and remains illuminated, followed by the next outermost lamp and so on until the outermost lamp lights briefly, at which point all lamps extinguish together and, after a short pause, the cycle begins again. The visual effect is one of outward motion in the direction of the intended turn or lane change. Sequential turn signals have been factory installed only on cars with red combination stop-turn lamps. They were factory-fitted to 1965 through 1971 model Ford Thunderbirds, to 1967 1973 Mercury Cougars, to Shelby Mustangs between 1967 and 1970, to 1969 Imperials, to the Japanese market 1971 1972 Nissan Cedric, and to Ford Mustangs since 2010. Two different systems were employed. The earlier, fitted to the 1965 through 1968 Ford-built cars and the 1971 1972 Nissan Cedric, employed an electric motor driving, through reduction gearing, a set of 3 slow-turning cams. These cams would actuate switches to turn on the lights in sequence. Later Ford cars and the 1969 Imperial used a transistorized control module with no moving parts to wear, break, or go out of adjustment. FMVSS 108 has been officially interpreted as requiring all light sources in an active turn signal to illuminate simultaneously. However, the 2010 and newer Ford Mustangs are equipped with sequential turn signals. Turn signal color. Until the early 1960s, most front turn signals worldwide emitted white light and most rear turn signals emitted red. The auto industry in the USA voluntarily adopted amber front turn signals for most vehicles beginning in the 1963 model year, though the advent of amber signals was accompanied by legal stumbles in some states and front turn signals were still legally permitted to emit white light until FMVSS 108 took effect for the 1968 model year, whereupon amber became the only permissible front turn signal color. Presently, almost all countries outside of the United States require that all front, side and rear turn signals produce amber light. In Canada and the US the rear signals may be amber or red. American regulators and other proponents of red rear turn signals have historically asserted there is no proven safety benefit to amber signals, though it has been recognized since the 1960s that amber turn signals are more quickly spotted than red ones. International proponents of amber rear signals say they are more easily discernible as turn signals, and U.S. studies in the early 1990s demonstrated improvements in the speed and accuracy of following drivers' reaction to stop lamps when the turn signals were amber rather than red. A 2008 U.S. study by the National Highway Traffic Safety Administration suggests vehicles with amber rear signals rather than red ones are up to 28% less likely to be involved in certain kinds of collisions, and a 2009 NHTSA study determined there is a significant overall safety benefit to amber rather than red rear turn signals. There is some evidence that turn signals with colorless clear lenses and amber bulbs may be less conspicuous in bright sunlight than those with amber lenses and colorless bulbs. Color durability. The amber bulbs commonly used in turn signals with colorless lenses are no longer made with cadmium glass, since various regulations worldwide, including the European RoHS directive, banned cadmium because of its toxicity. Amber glass made without cadmium is relatively costly, so most amber bulbs are now made with clear glass dipped in an amber coating. Some of these coatings are not as durable as the bulbs themselves. With prolonged heat-cool cycles, the coating may flake off the bulb glass, or its color may fade. This causes the turn signal to emit white light rather than the required amber light. The international regulation on motor vehicle bulbs requires manufacturers to test bulbs for color endurance. However, no test protocol or color durability requirement is specified. Discussion is ongoing within the Groupe des Rapporteurs des Permis Clairage, the UNECE Working Group on Vehicular Lighting Regulation, to develop and implement a color durability standard. Rather than using an amber bulb, some signal lamps contain an inner amber plastic enclosure between a colorless bulb and the colorless outer lens. Rear position lamps. Conspicuity for the rear of a vehicle is provided by rear position lamps. These are required to produce only red light and to be wired such that they are lit whenever the front position lamps are illuminated, including when the headlamps are on. Rear position lamps may be combined with the vehicle's stop lamps or separate from them. In combined function installations, the lamps produce brighter red light for the stop lamp function and dimmer red light for the rear position lamp function. Regulations worldwide stipulate minimum intensity ratios between the bright and dim modes, so that a vehicle displaying rear position lamps will not be mistakenly interpreted as showing stop lamps, and vice versa. LEDs are gradually coming to be preferred over filament bulbs as the light sources for vehicle rear lamps. Stop lamps, red steady burning rear lights, brighter than the rear position lamps, are activated when the driver applies the vehicle's brakes. These are called stop lamps in some countries and brake lights in others. They are required to be fitted in multiples of 2, symmetrically at the left and right edges of the rear of every vehicle. Outside Northern America, the range of acceptable intensity for a stop lamp is 60 to 185 candela. In Northern America, the acceptable range for a single compartment stop lamp is 80 to 300 candela. Center high mount stop lamp, in the United States and Canada since 1986, in Australia and New Zealand since 1990, and in Eurasia since 1998, a central brake lamp, mounted higher than the vehicle's left and right brake lamps and called a center high mount stop lamp, is also required. The CHMSL is also sometimes referred to as the center brake lamp, the third brake light, the eye-level brake lamp, the safety brake lamp, or the high-level brake lamp. The CHMSL may produce light by a single central filament bulb, a row or cluster of filament bulbs or LEDs, or a strip of neon tube. The CHMSL is intended to provide a deceleration warning to following drivers whose view of the vehicle's left and right stop lamps is blocked by interceding vehicles. It also helps to disambiguate brake versus turn signal messages in Northern America, where red rear turn signals identical in appearance to stop lamps are permitted, and also can provide a redundant stoplight signal in the event of a stop lamp malfunction. The CHMSL is generally required to illuminate steadily and not permitted to flash, though U.S. regulators granted Mercedes-Benz a temporary, limited exemption to the steady light requirement so as to evaluate whether a flashing CHMSL provides an emergency stop signal that effectively reduces the likelihood of a crash. On passenger cars, the CHMSL may be placed above the back glass, affixed to the vehicle's interior just inside the back glass, or it may be integrated into the vehicle's deck lid or into a spoiler. Other specialized fitments are sometimes seen. The Jeep Wrangler and Land Rover Freelander have the CHMSL on a stalk fixed to the spare wheel carrier. Trucks, vans and commercial vehicles sometimes have the CHMSL mounted to the trailing edge of the vehicle's roof. The CHMSL is required by regulations worldwide to be centered laterally on the vehicle, though UN Regulation 48 permits lateral offset of up to 15 cm if the vehicle's lateral center is not coincident with a fixed body panel, but instead separates movable components such as doors. The Renault Master van, for example, uses a laterally offset CHMSL for this reason. The height of the CHMSL is also regulated, in absolute terms and with respect to the mounting height of the vehicle's conventional left and right stop lamps. Depending on the left and right lamp's height, the lower edge of the CHMSL may be just above the left and right lamp's upper edge. The 1952 Volkswagen Bus was equipped with only one stop lamp, mounted centrally and higher than the left and right rear lamps which did not produce a stop lamp function. The 1968–1971 Ford Thunderbird could be ordered with optional supplemental high-mounted stop and turn signal lights integrated into the left and right interior trim surrounding the back glass. The Oldsmobile Tornado from 1971 to 1978, and the Buick Riviera from 1974 to 1976 had similar dual high-mounted supplemental stop-turn lights as standard equipment. These were located on the outside of the vehicle below the bottom of the back glass. This type of configuration was not widely adopted at the time. Auto and lamp manufacturers in Germany experimented with dual high-mount supplemental stop lamps in the early 1980s, but this effort too failed to gain wide popular or regulatory support. Effective with the 1986 model year, the United States National Highway Traffic Safety Administration and Transport Canada mandated that all new passenger cars come equipped with a CHMSL. The requirement was extended to light trucks and vans for the 1994 model year. Early studies involving taxicabs and other fleet vehicles found that a third, high-level stop lamp reduced rear-end collisions by about 50%. Once the novelty effect wore off as most vehicles on the road came to be equipped with a central third stop lamp, the crash avoidance benefit declined. However, it did not decline to zero, and a CHMSL is so inexpensive to incorporate into a vehicle that it is a cost-effective collision avoidance feature even at the long-term enduring crash reduction benefit of 4.3%. Emergency stop signal, Toyota, Mercedes-Benz, Volvo, and BMW have released vehicles equipped to convey a special light signal when the vehicle is braked rapidly and severely. This is officially referred to as emergency stop signal, and UN Regulation 48 calls for the lamps providing the ESS to flash at 4 Hz when a passenger car decelerates at greater than 6 ams2 or a truck or bus decelerates at greater than 4 ams2. Mercedes vehicles flash the stop lamps for the ESS, while vehicles from the Volkswagen group of manufacturers flash the hazard flashers. Other methods of severe braking indication have also been implemented. Some Volvo models make the stop lamps brighter, and some BMWs have adaptive brake lights that effectively increase the size of the stop lights under severe braking by illuminating the tail lamps at brighter than normal intensity. As long as the brighter than normal stop lamps are within the regulated maximum intensity for stop lamps in general, this kind of implementation does not require specific regulatory approval since the stop lamps are under all conditions operating in accord with the general regulations on stop lamps. The idea behind such emergency braking indicator systems is to catch following drivers' attention with special urgency. However, there remains considerable debate over whether the system offers a measurable increase in safety performance. To date, studies of vehicles in service have not shown any significant such improvement. The systems used by BMW, Volvo, and Mercedes differ not only in operational mode, but also in such parameters as deceleration threshold of activation. Data are being collected and analyzed in an effort to determine how such a system might be implemented to maximize a safety benefit, if such a benefit can be realized with visual emergency braking displays. An experimental study at the University of Toronto has tested stoplights which gradually and continuously grow in illuminated area with increasing braking. One potential problem with flashing stop lamps in the United States is the regulations that permit flashing stop lamps to be used in lieu of separate rear turn signal and hazard warning lamps. Rear fog lamps. In Europe and other countries adhering to UN Regulation 48, vehicles must be equipped with one or two bright red rear fog lamps, which serve as high-intensity rear position lamps to be turned on by the driver in conditions of poor visibility to make the vehicle more visible from the rear. The allowable range of intensity for a rear fog lamp is 150 to 300 candela, which is within the range of a U.S. stop lamp. Rear fog lamps are not required equipment in the U.S., however, they are permitted, and are found almost exclusively on European brand vehicles in North America. Audi, Jaguar, Mercedes, Mini, Land Rover, Porsche, Saab and Volvo provide functional rear fog lights on their North American models. The final generation Oldsmobile Aurora also had dual rear fog lights installed in the rear bumper as standard equipment. Most jurisdictions permit rear fog lamps to be installed either singly or in pairs. If a single rear fog is fitted, most jurisdictions require it to be located at or to the driver's side of the vehicle's central linear, whichever side is the prevailing driver's side in the country in which the vehicle is registered. This is to maximize the sight line of following drivers to the rear fog lamp. In many cases, a single reversing lamp is mounted on the passenger side of the vehicle, positionally symmetrical with the rear fog. If two rear fog lamps are fitted, they must be symmetrical with respect to the vehicle's center line. Proponents of twin rear fog lamps say two lamps provide vehicle distance information not available from a single lamp. Proponents of the single rear fog lamp say dual rear fog lamps closely mimic the appearance of illuminated stop lamps, reducing the conspicuity of the stop lamp's message when the rear fogs are activated. To provide some safeguard against rear fog lamps being confused with stop lamps, UN Regulation 48 requires a separation of at least 10 cm between the closest illuminated edges of any stop lamp and any rear fog lamp. Backup lamps. To provide illumination to the rear when backing up, and to warn adjacent vehicle operators and pedestrians of a vehicle's rearward motion, each vehicle must be equipped with at least one rear-mounted, rear-facing backup light. These are currently required to produce white light by U.S. and international UN regulations. However, some countries have at various times permitted amber backup lights. In Australia and New Zealand, for example, vehicle manufacturers were faced with the task of localizing American cars originally equipped with combination red brake turn signal lamps and white backup lights. Those countries' regulations permitted the amber rear turn signals to burn steadily as backup lights, so automakers and importers were able to combine the rear turn signal and backup light function, and so comply with the regulations without the need for additional lighting devices. Both countries presently require white backup lights, so the combination amber turn backup light is no longer permitted on new vehicles. The U.S. state of Washington presently permits reversing lamps to emit white or amber light. Rear registration plate lamp. The rear registration plate is illuminated by a white lamp designed to light the surface of the plate without creating white light directly visible to the rear of the vehicle. It must be illuminated whenever the position lamps are lit. On large vehicles such as trucks and buses are in many cases required to carry additional lighting devices beyond those required on passenger vehicles. The specific requirements vary according to the regulations in force where the vehicle is registered. Identification lamps. In the U.S., vehicles over 2032 and wide must be equipped with 3 amber front and 3 red rear identification lamps spaced between 6 and 12 inches apart at the center of the front and rear of the vehicle, as high as practicable. The front identification lamps are typically mounted atop the cab of vehicles. This type of identification lamp can also be found on road trains in Australia. Clearance lamps. In the US, vehicles over 2032 in wide must be equipped with left and right amber front and red rear clearance lights to indicate the overall width of the vehicle. These must be amber at the front, red at the rear, and mounted as high as practicable. End outline marker lamps. UN regulations require large vehicles to be equipped with left and right white front and red rear end outline marker lamps, which serve a purpose similar to that of the American clearance lamp. Intermediate side marker lamps and reflectors. U.S. regulations require large North American vehicles to be equipped with left and right amber side marker lights and reflectors mounted midway between the front and rear side markers. Rear overtake lights. Until about the 1970s in France, Spain, Morocco, and possibly other countries, many commercial vehicles and some Soviet road trains from Sovtransavto had a green light mounted on the rear offside. This could be operated by the driver to indicate that it was safe for the following vehicle to overtake. Emergency warning devices, hazard flashers. Also called hazards, hazard warning flashers, hazard warning lights, emergency lights, four-way flashers, or simply flashers. International regulations require vehicles to be equipped with a control which, when activated, flashes the left and right directional signals, front and rear, all at the same time and in phase. Operation of the hazard flashes must be from a control independent of the turn signal control, and an audio-visual telltale must be provided to the driver. This function is meant to indicate a hazard such as a vehicle stopped in or near moving traffic, a disabled vehicle, a vehicle moving substantially slower than the flow of traffic such as a truck climbing a steep grade, or the presence of stopped or slow traffic ahead on a high-speed road. In vehicles with a separate left and right green turn signal telltale on the dashboard, both left and right indicators may flash to provide visual indication of the hazard flash's operation. In vehicles with a single green turn signal telltale on the dashboard, a separate red telltale must be provided for hazard flasher indication. Because the hazard flasher function operates the vehicle's left and right turn signals, a left or a right turn signal function may not be provided while the hazard flashes are operating, although the vehicle may activate the indicator and return to the hazard flashing phase once the indicator is deactivated. Ret reflectors. Ret reflectors produce no light of their own, but rather reflect incident light back towards its source, for example, another driver's headlight. They are regulated as automotive lighting devices, and specified to account for the separation between a vehicle's headlamps and its driver's eyes. Thus, vehicles are conspicuous even when their lights are off. Regulations worldwide require each vehicle to be equipped with rear-facing red ret reflectors. Since 1968, U.S. regulations also require side-facing ret reflectors, amber in front and red in the rear. Sweden, South Africa and other countries have at various times required white front-facing ret reflectors. Variable intensity signal lamps. International Union regulations explicitly permit vehicle signal lamps with intensity automatically increased during bright daylight hours when sunlight reduces the effectiveness of the stop lamps, and automatically decreased during hours of darkness when glare could be a concern. Both U.S. and UN regulations contain provisions for determining the minimum and maximum acceptable intensity for lamps that contain more than a single light source. Experimental systems, multicolor auxiliary signals. Some jurisdictions, such as the U.S. states of Washington, Oregon and Idaho, permit vehicles to be equipped with auxiliary rear signal systems displaying green light when the accelerator is depressed, yellow light when the vehicle is coasting, and red light when the brake is depressed. Such systems have in the past been sold as aftermarket accessories, but are today seldom seen in traffic. Research and development. The U.S. National Highway Traffic Safety Administration, among other bodies, has commissioned studies of vehicle signal systems and configurations in an effort to determine the most promising avenues and best practices for enhanced crash avoidance via optimized vehicle conspicuity and signal lighting systems. Interior and convenience lights. Most cars have at least one dome light located in or near the ceiling of the passenger compartment, to provide illumination by which to fasten seatbelts and enter or exit the car. These often have an option to switch on when the front passenger doors are opened. Many vehicles have expanded this feature, causing the overhead interior light to remain on after all doors are closed, allowing passengers to fasten seat belts with added illumination. The extended lighting cycle usually ends when the vehicle's ignition has begun, or a gradual reduction in light emitted after a couple of minutes if the car isn't started, called theater lighting. Interior lighting has been added on some vehicles at the bottom edge of the dashboard, which illuminates the floor for front passengers, or underneath the front seats at the rear, to illuminate the floor for rear seat passengers. This type of convenience lighting approach is also sometimes used to illuminate interior or exterior door handles, exterior step running boards, or electric window switches. LED light sources appear increasingly as interior convenience lights in various locations, especially with finely focused lighting on console control surfaces and in cabin storage areas. Map lights are aimed at specific passenger positions and allow for reading without glare and distraction to the driver. Some vehicles have approach lighting in the exterior mirrors or lower edges of the doors, as well as interior lighting activated via key fob. Many cars have lights in the trunk, the engine compartment, and the glove box and other storage compartments. Modern pickup trucks usually have one or more white cargo lights which illuminate the bed of the truck, often controlled in conjunction with the interior dome lighting. Most instruments and controls on a dashboard in modern vehicles are illuminated when the headlamps are turned on, and the intensity of light can be adjusted by the driver for comfort. Saab automobiles, for example, have an aircraft-style night panel function which shuts off all interior illumination save for the speedometer to improve the driver's night vision. On service vehicles, emergency vehicle lights. Emergency vehicles such as fire engines, ambulances, police cars, snow removal vehicles and tow trucks are usually equipped with intense warning lights of particular colors. These may be motorized rotating beacons, xenon strobes, or arrays of LEDs. The prescribed colors differ by jurisdiction. In most countries, blue and red special warning lamps are used on police, fire, and medical emergency vehicles. In the United States and some other jurisdictions, amber lights are for tow trucks, private security personnel, construction vehicles, and other non-official special service vehicles, while volunteer firefighters use red, blue, or green, depending on jurisdiction. In the U.S., it is a violation of the DOT Uniform Vehicle Code for any non-emergency vehicle to operate forward-facing red lights of any kind. Cars in the U.S. only have red tail lights, and no blue lights. A vehicle displaying a red light coming towards you, or from behind you indicates to you that an official emergency vehicle is coming, requiring you to yield, pull off to the side of the road, or otherwise get out of its way. Some U.S. states allow emergency vehicles to have blue rear-facing lights that can be turned on to warn drivers behind them of an emergency vehicle in action ahead. Blue and red lights can be combined, forward and or rear-facing, also. Similarly, U.S. drivers are warned that police always use a red light, sometimes in combination with blue light, when attempting to pull you over for a moving violation, such as speeding. And any other color light could well be of malintent. In the UK, doctors may use green warning lamps although these do not allow the user to claim any exemption from road traffic regulations compared to the blue lights used by statutory emergency services when responding to calls. Special warning lights, usually amber, are also sometimes mounted on slow vehicles such as mobile cranes, excavators, tractors, and even mobility scooters in certain conditions. Taxi displays, taxicabs are distinguished by special lights according to local regulations. They may have an illuminated taxi sign, a light to signal that they are ready to take passengers or off duty, or an emergency panic light the driver can activate in the event of a robbery to alert passers-by to call the police. Light sources. Incandescent lamps. The incandescent light bulb was long the light source used in all automotive lighting devices. Many types of bulbs have been used. Standardized type numbers are used by manufacturers to identify bulbs with the same specifications. Bases may be bayonet type with one or two contacts, plastic or glass wedge, or dual wire loops or ferrules used on tubular festoon lamps. Screw-base lamps are never used in automobile applications due to their loosening under vibration. Signal lamps with internal or external colored lenses use colorless bulbs. Conversely, lamps with colorless lenses may use red or amber bulbs to provide light of the required colors for the various functions. Typically, bulbs of 21 to 27 watts, producing 280 to 570 lumens, are used for stop, turn, reversing and rear fog lamps, while bulbs of 4 to 10 AW, producing 40 to 130 ALM, are used for tail lamps, parking lamps, side marker lamps and side turn signal repeaters. Tungsten halogen lamps are a very common light source for headlamps and other forward illumination functions. Some recent model vehicles use small halogen bulbs for exterior signaling and marking functions, as well. The first halogen lamp approved for automotive use was the H1, which was introduced in Europe in 1962, 55W, producing 1500 lumina. Light-emitting diodes. LEDs are being used with increasing frequency in automotive lamps. They offer very long service life, extreme vibration resistance, and can permit considerably shallower packaging compared to most bulb-type assemblies. LEDs also offer a potential safety benefit when employed in stoplights, because when power is applied they rise to full intensity approximately 250 milliseconds faster than incandescent bulbs. This fast rise time not only improves the intentional conspicuity of the stop lamp, but could also provide following drivers with increased time to react to the appearance of the stop lamps. However, this faster rise time has not been shown to make cars with LED stop lamps less likely to be struck from behind. LEDs were first applied to automotive lighting and center high-mount stop lamps, beginning in the late 1980s. Adoption of LEDs for other signal functions on passenger cars is gradually increasing with demand for the technology and related styling updates. In North America, the 2000 Cadillac DeVille was the first passenger car with LED taillights. The 2002 Kia Opera Samanti was an early adopter of LED front turn signals. The 2007 Audi R8 sports car uses two strips of optically focused high-intensity LEDs for its daytime running lamps. Optional on the R8 outside North America was the world's first LED headlamp made by AL Automotive Lighting. The low and high beams along with the position lamp and front turn signal are all realized with LEDs. The Lexus Ls 600H features LED low beam, position and side marker lamps in North America, and the 2009 Cadillac Escalade Platinum uses LEDs for the low and high beams, as well as for the position and side marker lamps. The Mercedes-Benz S-Class has no non-LED lamps at all, not even in the most basic trim level. The commercial vehicle industry has rapidly adopted LEDs for virtually all signaling and marking functions on trucks and buses, because in addition to the fast rise time and concomitant safety benefit, LED's extremely long service life reduces vehicle downtime. Almost all commercial vehicles use exterior lighting devices of standardized format and fitment, which has cost-reduced and sped the changeover. LED lamps are used for flashing beacon lights on vehicles such as maintenance trucks. Previously, traditional light sources required the engine to continue running to ensure that the battery would not become depleted if the lights were to be used for more than a few hours. The energy-efficient nature of the LED source allows the engine to remain turned off but the light to continue to flash. LED lighting systems are sensitive to heat. Due to the negative influences of heat on the stability of photometric performance and the light transmitting components, the importance of thermal design, stability tests, usage of low UV type LED modules and UV resistance tests of internal materials has increased dramatically. For this reason, LED signal lamps must remain compliant with the intensity requirements for the functions they produce after 1 minute and after 30 minutes of continuous operation. In addition, UN Regulation 112 contains a set of tests for LED modules including color rendering, UV radiation, and temperature stability tests. According to UN Regulations 112 and 123, mechanical, Electromechanical or other devices for headlamps must withstand endurance tests and function failure tests. High-intensity discharge. High-intensity discharge, or HID lamps, sometimes referred to as xenon lamps, are modified metal halide lamps employing xenon fill gas. Traditional HID lamps such as those used for general lighting have a long warm-up time. Headlamps must provide light very shortly after they are turned on, and xenon gas serves to reduce start-up time. Neon tubes. Neon lamp tubes were introduced into series production for the center high-mount stop lamp on the 1995 Ford Explorer. Notable later uses included the 1998 Lincoln Mark 8 with a neon tube spanning the width of the trunk deck lid, and the BMW Z8, which made extensive use of neon. Concept cars such as those from Volvo have included neon lamp features. Hella offered an aftermarket neon CHMSL in the late 1990s. The linear format of the neon light source lends itself to center high-mount stop lamp installation, and neon lights offer the same nearly instant rise time as LEDs. However, neon tubes require a ballast. Distributive lighting. In distributive light systems, the light from a single source is sent via optical fibers or light guides to wherever it is needed in the automobile. Light guides are commonly used to distributively light dashboard displays, and premium vehicles are beginning to use distributive systems for lighting such items as door locks, window controls, and cup holders. Distributive exterior lighting has also been explored, with high-intensity central light sources. See also. References. External links. Turn signal patent, issued 1909, car lights flash warning signals, a Euro 1951 article on first hazard flashes.